Alright, hello and welcome, ladies and gentlemen, to another edition of my Java video tutorials, freely available videos. As always, I am Trevor Page. I am the instructor and the creator of JavaVideoTutorials.net. And today I just wanted to record a quick video on sorting because I had a question come in from someone with regards to the sorting subject. So I'm going to go ahead and hopefully answer that question and sort everything out. I'm going to go ahead and create a new class, and I'm just going to create a tests class because I like to create unit tests to actually test the code that I've created. So if you're not familiar with unit tests, then that's okay. I'm sure I'll publish another video on unit testing, but for now, I'll stick with the subject at hand, which is sorting. So I'll create a public void test class for now, and import my stuff, add JUnit4 to the library, JUnit4 library to the build path, and I'm going to create a users object. Okay, so when it comes to sorting, there are two different interfaces that you need to be familiar with. There's the comparable and the comparator. Okay, so these are two interfaces defined by Java that allow us to sort, essentially. Okay. Now the real question is, okay, well, why are there two interfaces, and when do you use one over the other? So that's exactly what I'm about to show you. The comparable interface usually you would use in tandem with a custom object that you're creating that just needs to be sorted in some way, shape, or form. You can define a custom sort of sorting algorithm if you wish. So let me go ahead and create a users object. I'm just going to hover over it and say create class users, and I'll just throw it inside of the sorting package that we're dealing with right now. And I'm going to create a very basic users object. So I'm going to create two instance variables. One's going to be a username, and one's going to be a password. Okay, kind of the building blocks for any old users object. And I will also create my getters and setters, like so. And there you go. So that's sort of the building blocks for a user's object. Now, if I were to go ahead and try to sort this user's object, you can actually use something called the collections.sort. Okay. Now, collections.sort is a static method that takes a list. Okay. So right now, I just have a user's object, which is obviously not a list. I need to actually create a list. So I'm going to create such a thing, and the list that I'm going to create is going to be a list of users. Okay, so I'm going to go ahead and instantiate a new array list of users, like so, and import array list, and I'll say list.add, and I'll add the user that I've just created, and perhaps I will set the username and password just so we are dealing with an object that actually sort of makes, somewhat sense, some sort of logical sense. Now, I want to go ahead and save this. So I've created a user object, and I've added it to an array list, like so. And now I'm asking to sort this array list. Now, obviously, it doesn't make much sense to sort it because there's only one object inside of it. But as you can see, there's a problem here. It's the sort method has a compilation error, and it gives us this long, sort of nasty error message complaining about the list of users. And really what it's saying is this list of users, the actual users object, does not use a comparable interface. So in order for us to actually invoke the collections.sort method to actually sort our list, we need to be using this comparable interface. So how do we do that? Well, we go into the users object that I've just created, and we need to actually implement the comparable interface. So once I've implemented the comparable interface, I'm able to use it, and I need to obviously abide by the contract that the comparable interface sort of applies on us. So the contract that I need to abide by is to override the compare_to method. So if I go inside of the comparable object, I'm going to hit F3 here and go inside of it. You see that it's a public interface, and it defines one method, which is the public int compare_to method, okay, which takes a generic type here. So this T stands for a generic sort of template type. It could be a string, it could be an integer. You can sort of swap in whatever kind of type that you'd want to have in there, and that's what it sort of it allows us to be able to implement this compare to method in some way, shape, or form. So once again, we've implemented that interface, so we need to abide by the contract and add the unimplemented methods, which when I click on this will be implemented. So there you go. We've now implemented the compare to method, which I just showed you. It comes from the actual comparable interface that we've just implemented. So fair enough. Now when I save this and go back to my test class, you see that collections.sort is no longer gives us a compilation error. Now it's just a warning because we're using an unchecked collection. Okay, so what's going on here is I haven't necessarily defined what it is that I'm going to be sorting on. So if I do this and just say implements comparable, you see here that it's using a compare to and saying object. Okay, so we haven't actually defined that generic type. So if you go back to the comparable class, you see that this T represents a generic type. So we can actually use and specify a type in there. Okay, just like I did here with my my list of users. I've actually defined users to be as part of the list. So the list is going to be, or it's going to contain user objects. So I can apply the exact same methodology to my comparable. I can actually say, I want to compare based on strings. Okay, so now obviously since I've changed this to be a string, now it's upset here because this doesn't abide by the contract anymore, so we need to change this to be an actual string. Okay, and then it goes back to being happy. So the string that I want to compare to could be like the username perhaps. So I could specify username here just to be a little bit more explicit if I like. Or when it comes to comparable, you can kind of put whatever you want in here. You can even put the whole user's object, okay? And obviously if I put the user's object up top, I need to match it in the compare to method, all right? So that's the first sort of hurdle that you run into with respect to comparable. But the next thing you need to do, or that you need to know, is how to actually implement the compare to method. Because right now it just says return 0. So what's happening inside of this compare to method is Java wants to take the instance of the variable. Okay, so at any given moment, the instance that we're working with for a particular user's type, user's object, can be compared to another user's object. All right, and that's the one that we are passing in to the actual method here, the compare to method. So let me go back to my tests class. And let me add, let me add another user. So let me create users, user2 equals new users. And I'll say set username equal to, I don't know, let's do Z page instead of T page. And I'll explain why I'm doing that in 1 second while I type in my password here. So what I'm going to do is I want to be able to compare these two users based on their usernames. Because hey, why not? That's just what I want to do. That's my implementation that I want to have inside of this sort of comparing method, and I want to compare usernames. So if I'm comparing two usernames, I'm just comparing the actual strings to each other. And in the alphabetical series, T page is before Z page because the letter T comes before the letter Z, and these two strings are the same length. Okay, so if I were to sort, I would expect that user should come before user2, just based on the fact that the first letter is comes before this first letter here of this username. So let me go ahead and add user2, to my list, user2, and invoke the collections.sort. But what I want to do is I want to add them in reverse order, because right now if I add user2 first, then I know that it's out of order. Okay, and then when I invoke the collections.sort, I can assume that it will be in a sorted order. So now I want to create an actual assertion statement to go along with my test class here. And in order to do that, I think I need to do an import static, org. Let me think here. Is it JUnit? I believe so. .assert. Let's just do .star for now. And assert that. There we go. So I want to assert that, the first element inside of my list, and I get the actual username is, and that is, I might need to do another static import for hamcrest there to use the is identifier. Hamcrest dot, is it core matchers? I never know the answer until I just type this in. Is, yes, that's the one. And I want the first element of the list, the username, I expect it to be tpage, because when it's sorted, the first element should obviously be the user tpage. And then I obviously want to assert that the second item in the list is zpage, because the proper order should be tpage first and then zpage. So if I run this unit test, what do you think is going to happen given what it is that we've done inside of the Compareto class? Because one thing I haven't said yet, when you invoke the collections.sort on a list, it actually looks at the types that are in the list. So in this case, it's a users type. And it will invoke the Compareto method that is obviously part of that type. So it's going to invoke this Compareto method. So what do you think is going to happen? Well, let's find out. Let's run it as a JUnit test and see what we get. So we get a failure. There's the assertion error. Well, actually, it's something completely different. The expected output was tpage, and we actually got null. So that's actually not what I was expecting, and this is why I record these videos, because, hey, even the experienced programmers like myself make mistakes. So if I go here and I say, well, the expected is tpage, but it got null, so that means that, well, either the list is null or the username itself is null. So if I look, obviously I'm adding things to the list, so those can't be null. But the username here, I see that I've messed up with this right here. So this should not say user.setUsername, it should be user2.set username and password. So my apologies for that. Let me run it again and get back to the topic at hand, which is sorting. So there you go. We have an assertion error saying we expected to get tpage, but instead we got zpage. So why that happened was because of our implementation of the Compareto method. Right now, all it's doing is saying return 0, okay, which is actually not a good way to implement a Compareto statement. And the reason for that is Compareto should actually return one of three values. So one of three values that it should return is a 1, 0, or a -1. All right, and I'll explain why that is. Java uses these numbers to determine how it should actually go about sorting objects inside of a list. If it returns 1, then that means that this particular object is greater than the object we're comparing to or against. 0 means this particular object is equal to the object we're comparing against, and this -1, sorry, I like to be consistent here with a capital this, particular object is, I'm sure you can guess it, less than the object that we're comparing against. And when I say the object we're comparing against, I mean this object right here, okay? User's username. Okay, now obviously user's username doesn't make much sense because I had this pointing to a string before, so really this should say user, because the user's object should point to a user, not a username, because obviously username is inside of a user's object. Anyway, so I should actually make this say user. And obviously it's the same thing for each one of these. The object we're comparing against is the object that we're passing in, versus the object that we have in the beginning here, which is it has to be this particular instance. Okay, so what that means is if we are comparing against user names, let's say, we can say this, okay, dot get username, or even just username. I guess it doesn't make sense, or it doesn't matter which one we use, and we can say compare to another string, which is the one that we're passing in, okay, the user object that we're passing in, and we can get the username from that object that we're passing in, all right? And then we can return that value, because if I'm invoking the Compareto, I'm actually invoking the string Compareto, which has already been created by Java on our behalf, okay? And the reason why it's using the string Compareto is because I'm using the username, and invoking the dot compare_to property on the username, which is already defined as a string. Okay? So, in other words, I'm comparing this particular object's username to the user that we're passing in to our method, our compare_to method. Okay? So now all this is doing is comparing, obviously, usernames, one to the other. So now if we go back to our test and we run this, what do you think is going to happen? Now we get a green bar because it's properly sorting our list. And again, it's doing that because of the fact that we are comparing usernames against each other, and it's returning an integer value based on the comparison. So if I go in and actually debug this process, if I set a debug breakpoint right here, and let's say I set a breakpoint in the collections.sort, and I run this in debug mode, it's going to switch perspective on me. So if I run this in debug mode, you see it stops here at the collections.sort, and if I just say, if I hit F8 or hit resume to just let the program run its course, you'll see that it breaks one more time. I'm going to hit OK and go. You see it breaks again, and it breaks inside of the compare_to method because we've just invoked the sort, the collections.sort method, which obviously we're invoking it on the user's object. So if we point to this keyword, we can see exactly what this is referring to. Okay, so we see that this is referring to the username tpage. Okay, and tpage is being compared to the user that's being passed in, which is zpage. So you see how there are two different objects here? This points to tpage, and user points to zpage. Okay, so two different objects are being compared to each other. So what do you think is going to be the result? What is tpage dot compare to zpage? What should it return? Well, look at this. It returns 1 if this object is greater than, it returns 0 if they're equal, and it returns -1 if it's less than. So since we're comparing username, the this.username, which is tpage, against the one that we're passing in, the question is tpage greater than, equal to, or less than user.getUsername, which is zpage. So really all we're asking is t less than, equal to, or greater than z? And of course, hopefully you can understand that t comes before z in the alphabet, therefore t is less than z. So since t is less than z, we should be receiving a -1 here. So let me just go and highlight this code, and I'm actually going to go ahead and do an inspect to see what it actually returns. So I click on inspect. So here you see that it shows -6. So I was actually simplifying things a little bit when I'm saying 1 versus 0 versus -1. Really what I mean to say is that it returns either a negative number, a 0, or a positive number. Okay? So if it returns a negative number, then this is the situation that we're hitting. And when we hit this situation, what happens is Java does nothing to do it for the actual sorting method or sorting algorithm, because if this username comes before this one, then it's already in perfect sorted order. Whereas if it's the other situation, if it returns a positive number, then they're out of order, which means that the object that is greater is actually appearing before the object that is less than. Okay, so to illustrate this in terms of numbers, let's say we have 1, 2, 3, 4, 6, 5. Okay, so when we compare 1 to 2, 1 is less than 2. Therefore, we will receive a negative number being returned from the compare_to method, which means that everything is a-okay. Then we compare 2 to 3. And again, 2 is less than 3, so we get a negative number. Therefore, everything is a-okay. 3 to 4, we get a negative number, everything's a-okay. 4 to 6, still, everything is okay because 4 is still less than 6, so we get a negative number. But here we get 6 and 5. So 6 is greater than 5, which means we get a positive number. Okay? So if we get a positive number, that means that it is out of order and it needs to be switched. And Java will do just that. It will switch the two right in their place so that it's properly sorted. Okay? So that is the magic that's happening here behind the scenes. So let me go ahead and run this this program once again. Where can I run that easily? Let me switch back to my Spring View and sorry, to my tests. There we go, and run my unit tests. Debug. So debugging again, we go back to the collections.sort. Fair enough. I hit next, and it goes into the Compareto method. This time, okay, we're comparing tpage against zpage, I assume. Yep. So then, obviously, it will be returning a negative number because tpage is less than the zpage. Fair enough. I'm going to hit play, and there we go. So that's the comparison that was made, and Java will actually do something to the actual list. It will actually modify the list depending on what it actually gets back from that Compareto method. Okay, so there we go. That's sort of how the comparable class works when you're dealing with objects. Okay. Now I say objects in terms of objects that we have customized for ourselves for use inside of our programs. But what happens if we're dealing with something like just a plain old string? Okay, and what happens if we want to implement our own sort of sorting algorithm on a string? Well, what would we have to do? Well, based on what I've just taught you, you'd have to declare a public class string, make it implement comparable sorting on string, and then create your own Compareto method. So that's not going to work because we can't create a string class because it's already being used by Java. So then, okay, what else can we do? Well, maybe we can create a class that extends string and then implements comparable. Can we do that? I don't believe so. And let's find out if we can do that or not, because that is an important question. So let me create a new class. Let me say, call it substring or something like that. And let's say extends string and save. So now what's happening? The type substring cannot subclass the final class string. So if we actually go in and look at the string class, we see that it's declared final. And if a class is declared as final, we are not allowed to subclass it. We're not allowed to extend that class. So then if we can't subclass the string class, then how the heck are we going to implement our comparable on an object like string? Or perhaps we're just not allowed to. We can never create a custom sorting method for any strings or any other objects that Java has declared as final. But that just doesn't feel right, does it? Well, that goes back to the beginning where I was talking about two different interfaces, comparable and comparator. So let me show you what the comparator is all about with a new test. So let's say we have two strings. String, let's see, I'll call it str1 equals tpage, and string str2 equals zpage. So you see where I'm going with this? And then I want to create a list and add these to the list. But obviously I don't want to be using users, I want to be using strings. So I want to have a list of strings, and I want to add both of these to the list. String 2. All right, so does that make sense so far? And again, let's make them in reverse order. And then let's do the exact same thing as we did before, which was to assert that get 0 and get 1. So it should be in this order. When you say get 0, we're getting the first element. The first element is expected to be tpage, and the second element is expected to be zpage. So now we want to say collections.sort, and we want to sort on our list. Now, if we just do this, we're not actually using the comparator or comparator interface, okay? And this actually will work if I run this JUnit test. Oh, I have errors in my project. Where are the errors? Interesting. Let me run JUnit test. Errors exist in project. Oh, sorry, substring. There we go. Let me delete our substring because we don't need it. There we go. And run this test. So you see I get a green bar, which means that everything is being sorted properly. But what happens if we want to create our own sort of sorting algorithm? And what I mean by that is what happens if I do this? What happens if I change the Z to be a capital Z, okay, and therefore I need to change the expected result to be capital Z? You would expect that nothing would really happen here because I'm inserting string 2 first. I'm inserting the capital Z page into the list first, and then I'm inserting the lowercase t page into the list second, and then I'm invoking the sort, and I'm expecting it to properly sort, t page to go first and z page to go second, just like we saw before. So now let me actually go ahead and run this. And you see that there's an assertion error. Expected as T page, but we got Z page, the capital Z page. And that is because Java actually has a different way of sorting uppercase versus lowercase. It thinks, or it claims, that the uppercase letters should have a sort of lower sorting standard than the lowercase letters. So that means that uppercase letters should be sorted first, or have a lower value, if you will, than the lowercase letters. So that's messing up our algorithm here. Well, here's the scenario, right? This is the scenario that I'm talking about where, well, now we need to create a custom sorting method for strings, but we can't do that with the comparable, can we? Well, not exactly. So what we can do is create an actual comparator. And one way to do that is to look at the actual sort method that we have here. So let me go in and open up sort, and you see that there is another static method called sort that takes in a list and a comparator. All right, so that's the one that we're interested in. So now what I can do is I can pass in my list, just like before, and now I need to give it a comparator. So now, like I said, comparator is an interface, but we can sort of do a little trick here. We can say new, and not tests, we can say new comparator, and we can actually create an anonymous inner type. Okay, so if I double click on this, it's going to create something called an anonymous inner type. And that allows me to sort of implement the normal methods that I would need to override inside of the scope of this anonymous inner type. So I can actually say add unimplemented methods. But before I do that, I want to specify what it is that I want to be sorting on. I want to sort on strings, okay? So now I can say add unimplemented methods, and voila, it now creates the compare method. Okay, it doesn't create a compare to, because we're not comparing one object to the other based on the this keyword. We're comparing these two objects that we're passing in, two strings, O1 and O2. All right? So now, you're familiar with this. You've seen the return 0, and you see that it doesn't work like you think it should. So what are we going to do? Well, we can just create our own return method here that creates our own compare method, like so. We can say O1, and I can say dot compare to another string, but I want to ignore the case. So that is the big difference between what Java does by default and what I'm allowing it to do based on my own special implementation of this compare method. So if I ignore the case, then I'm able to ignore the fact that I'm comparing the uppercase Z to the lowercase t. So I'm going to go ahead and say save, and I'm going to run this again and show you what happens. So there we go. Now we are ignoring the cases of the two first letters, the T versus the Z, and we get the green bar. So there we go. There's your quick little comparison between when you'd want to use the comparator versus the actual comparable interface, which is usually defined inside of the actual object itself. Okay, so if you have your own objects that you've created, they're custom to your actual application, and you're going to be using this comparable a lot, then there you go. You can define it within the object, and then it just so happens that when you call the sort, it knows exactly what to do because it looks to the actual comparable interface and the compare to method that you have registered inside of your custom object. But if you're not using a custom object, if you're using something like a string or integer or something like that, and you want to sort of define your own custom sorting method for your strings or your integers, then you would use the comparator along with the actual collections.sort method, pass in that comparator, override the compare method, and give yourself a custom compare method to use for the actual comparisons and sorting. All right, so hopefully that's helpful to you. If you want to hear more of these kinds of tutorials, you can head over to javavideotutorials.net, where I go into painful detail of all the different aspects of Java, including sorting, and plus there's a bunch of tests and assignments and forums that you can post on and ask questions and interact with the developer community inside of Java Video Tutorials, because it's full of students just like yourself who are trying to learn the language and want to get ahead in life. All right, so head on over there, check it out, and I look forward to seeing you there. So happy learning.